Welcome friends. Let us continue to study heat engines on my YouTube channel. Kindly like, share and subscribe my YouTube channel. The topic included in today's lecture is comparison between Otto and diesel cycle. So let us draw the PV diagram for the Otto cycle. Process number 122, that is the isentropic compression, and on the TS diagram it is a vertical line. Process number 223, constant volume heat supply, that is vertical line on PV diagram and curve on TS diagram. Process number 324, that is isentropic expansion, that is curve on PV diagram and vertical line on TS diagram. Entropy remains constant, so S3 is equals to S4. And last one is 421, constant volume heat rejection, that is vertical line on PV diagram and curve on a TS diagram. So this is the PV diagram and TS diagram for the Otto cycle. And the efficiency of Otto cycle equation is 1 minus T4 minus T1 divided by T3 minus T2. That is equation in terms of temperature. And another equation is 1 minus 1 upon R raised to gamma minus 1. Now let us draw the PV and TS diagram for the diesel cycle. Process number 122, isentropic compression process. So that is curve on PV diagram and vertical line on TS diagram. That is S1 is equals to S2. Process number 223, that is constant pressure heat supply. So as a heat supply is constant pressure, it is horizontal line on PV diagram and curve on TS diagram. Next process is isentropic expansion process, that is curve on PV diagram and vertical line as the entropy is constant on TS diagram, and therefore S3 is equals to S4. And the last process is constant volume heat rejection, that is vertical line on PV diagram and curve on TS diagram. So that is the PV diagram and this is the TS diagram for the diesel cycle. And the equation of air standard efficiency of diesel cycle is 1 minus 1 upon gamma into T4 minus T1 divided by T3 minus T2 in terms of temperature, and other equation for the air standard efficiency of the diesel cycle is 1 minus 1 upon R raised to gamma minus 1 multiplied by rho raised to gamma minus 1 divided by gamma into rho minus 1. Now comparison between Otto and diesel cycle. Now before we compare, now let us study two fundamental. One is enclosed area on PV diagram indicates net work done by the cycle. So if this is a cycle, that is 1, 2, 2, 2, 3, 3 to 4 and 4 to 1, then this enclosed area indicates that this is the net work done by the cycle. And if we have enclosed area on TS diagram, it represents the heat supplied to the cycle. So consider this is the TS diagram of one cycle. That is 1 to 2 another process, 2 to 3, 3 to 4 and 4 to 1. So this is the enclosed area on TS diagram, and that enclosed area indicates heat supplied to the cycle. Now let us compare the Otto and diesel cycle for the criteria same compression ratio and same heat supply. It can be compared using the another criteria, same compression ratio and same heat rejection. And third one is for same maximum pressure, maximum temperature and heat rejection. So the Otto and diesel cycle can be compared using these three criteria. So let us select the first criteria. For same compression ratio R and same heat supply. So this one is which cycle? So I have drawn one cycle on PV diagram. 1, 2, 3, 4. and this cycle represents the Otto cycle. Now if I have to maintain the same compression ratio, my 1-2 should be same because compression ratio is V1 by V2. So 1-2 points should not be changed. And another one is same heat supply. So the quantity of heat supply should remain same. So in that case, if I have to draw the diesel cycle on the Otto cycle in a such a way that 1-2 point are same, then I can draw like this. Point 1 and point 2 are fixed for the diesel cycle and heat supply is same. So let us draw. So 1 to 2 is same. 2 to 5 is the heat supply in diesel cycle, which is equal to 2 to 3 in Otto cycle. 5 to 6 expansion and 6 to 1 heat rejection. So the diesel cycle is 1 to 5, 6, 1 is the diesel cycle where 1 and 2 point are common. It means is the same compression ratio. And 2 to 5 is equals to 2 to 3. That is the same heat supply is there for both the cycle, Otto and diesel cycle. Now you look at this. Work done. Work done means what? Area under PV diagram. So area under PV diagram of which cycle is more? So the area under PV diagram for Otto cycle is more than the area under PV diagram for the diesel cycle. It means work net for the Otto cycle is more than the work net for the diesel cycle. And therefore, efficiency of Otto cycle is greater than efficiency of diesel cycle. Because we know that efficiency is work done upon heat supply. Work done of Otto cycle is more and heat supply for both the case are same. And due to that, efficiency of Otto cycle is always greater than efficiency of diesel cycle for the case same compression ratio and same heat supply. Now let us select another criteria. Same compression ratio and same heat rejection. Now let us draw the again first Otto cycle. So 1, 2, 3, 4 is the Otto cycle. 1, 2, 3, 4, 1 is the Otto cycle. Same compression ratio means 1, 2 should be the same. Another same heat rejection, that is QR should be the same. So now let us draw the diesel cycle. 1, 2 are fixed and heat rejected is same. So in that case, 1, 2 is the same compression ratio, that is the diesel cycle. 2 to 5, again the heat supply process. 5 to 4 and 1. So that is the diesel cycle. So 1, 2, 5, 4, 1 is the, you can say diesel cycle. Now you look at it this. In which case the work done is more? 1, 2, 3, 4, 1 or 1, 2, 5, 4, 1? Right. Work net for the Otto cycle is greater than the work net for the diesel cycle. And due to that, efficiency of Otto cycle is more than the efficiency of diesel cycle. For which case, same compression ratio and same heat rejection. Now let us study the third case. Same maximum pressure, maximum temperature and heat rejection. Now let us draw the again. So this one 1, 2, 3, 4, 1 is the Otto cycle. Now what we have to make the same? Maximum pressure and maximum temperature of the cycle should be same. Right? So maximum pressure means 3 should be same. Let us draw it. So 1, 5, 3, 4, 1 is the same, or that is the diesel cycle. So 1, 5, 3, 4, 1 is the diesel cycle and 1, 2, 3, 4, 1 is the Otto cycle. Now from these two cycles, can you identify for which cycle work done is more? Yes, work done for the diesel cycle is more than the work done for the Otto cycle. And due to that, efficiency of diesel cycle is more than the efficiency of Otto cycle. It means if we have the same maximum pressure, maximum temperature and heat rejection, then efficiency of diesel cycle is more than the efficiency of Otto cycle. Kindly ask your queries in the comment box. Kindly like, share and subscribe my YouTube channel. Thank you.